Hi, everyone. My name is Hong Jian. I am currently leading the corporate efforts at AmSpec for carbon accounting, lifecycle assessment, and sustainability services. I have been practicing lifecycle assessment since 2006. I was heavily involved in the rulemaking processes for the Federal Renewable Fuel Standard, RFS, and also the California Low Carbon Fuel Standard, the LCFS program. In 2007, providing comments to the existing rules for various biofuels pathways, and evaluating the assumptions and default values that are used in the models that were adopted. Today, I want to talk specifically about the amendments that were recently released for the California Low Carbon Fuel Standard. The amendments were in effect July 1st, 2025, among various anticipated updates from the models as well as the implementation guidances. There is one particular item related to the new feedstock mapping as well as the sustainability requirements. They were causing a lot of anxieties, uncertainties, and debates. This is a topic I want to go a little in depth today. So, what is the feedstock traceability? Feedstock traceability means a chain of custody verification, including transfer of documentation for sales, attestation letters, and third-party verifications about the feedstock materials, whether it's agricultural products where it traces all the way to the farm, or it's a waste material like used cooking oil where it's traced all the way to the restaurants where it was collected. This traceability requirement was implemented in the amendments to avoid fraud in the creation, transportation, as well as delivery process to the biofuels production facilities. And then the updates in the LCFS amendments were the inclusion of indirect land use change impact, iLUC, could create significant rise in the carbon intensity for the biofuels, and therefore reducing the credits producers could potentially qualify. There's a lot of discussions and public comments submitted to CARB requesting the iLUC language to be examined rigorously and even be removed. On November 6th, CARB has facilitated a specific workshop on the land use change topic. As many of you already know, it just leads to even more debates and discussions rather than conclusions. Today, I want to go a little bit further in depth to explain what are the fundamental drivers to these amendments. What are some of the key issues that people need to pay attention to? And as a complying party, what do you need to make sure you're going to stay in compliance? I would also give my little prediction about what the future for these amendments lie in. So first, I want to take a step back into the history and how it has been evolved. As you can see from the timeline, indirect land use change debate started in 2008, 1 year after RFS and the California LCFS were in place. And that is because there were concerns the biofuels boom could potentially lead to competition for agricultural land and therefore deforestation in South American and Indonesia rainforests, which are huge carbon sinks. Removing those could cause a counter effect in terms of mitigating climate change impact. There were debates as early as 2008 on inclusion of indirect land use change and carbon intensity associated with the land clearance to add these CI values into the biofuels carbon intensity, using that as a countermeasure to cool the biofuels boom and prevent overproduction and land clearance. At that time, the uncertainties for the iLUC calculations were so big, and it was impractical to implement the iLUC value. The research is going on, trying to understand the land use change impact and calculate the carbon intensity associated. It's been going on for 17 years, almost 2 decades. And I'll show you some of the most recent research and how that uncertainty value still lies today. And you can also see from this timeline that the ICC, the sustainability certifications for chain of custody, has been developed in 2010 to ensure that there is a transparent and consistent tracking of biomass production, logistic transportation, all the way to production and end use, and to make sure that renewable fuels are indeed renewable and there's no fraudulent claims generated for these renewable feedstocks and renewable fuel production. As you can see from this timeline, those topics have evolved over the past 2 decades and lots of knowledge has been accumulated over this time. And the reason why we brought them back is because in the past 3 years, ever since the Inflation Reduction Act 2022 was adopted, there is a boost for biofuels to make sure enough low carbon fuels are supplied to the market. We're in a new era where carbon has been highly integrated in our economy. It's not only impacting the transportation sectors. We're seeing marine fuels, we're seeing sustainable aviation fuels. We're also seeing carbon tariffs, like the Carbon Border Adjustment Mechanism, CBAM, that's passed in the European Union to make sure that the heavy industries, high carbon intensive industries are all regulated based on the carbon footprint. Even though there are setbacks in some of the regulations, we're seeing more integration as we move forward. This indirect value chain, in fact, and the chain of custody issues are going back to make sure that policies are developed in accordance with the environmental impact to prevent unintended consequences. Let's first look at the chain of custody and traceability issues. The chain of custody is a measure to make sure we have a transparent and consistent system to track the product or material production from its origin to its final end use. It gives a way to verify, validate, and produce a sustainability claims regarding how we manage the natural resources as well as the products. There's 3 ways to implement chain of custody systems. One is called the bulk commodity. It's the physical segregation of the product. It's the most traditional way we track the flow of transactions and chain of custodies. Another one is called book and claim. Those are the certificates that can be traded. The third one is called mass balance. It's basically a physical units in equal to units out. The mass should close for every chain of custody transfer. It is endorsed by majority of the regulations, like the United Kingdom Renewable Transportation Fuel Obligations, the ICC CORSIA Standard for Sustainable Aviation Fuels, the British Columbia and the California Low Carbon Fuel Standard. As you can see from this table here, not all traceability requirements are created equal. Let's just take one example, the definition of a site. As you can see from this table shown here, site could mean different things in different regulations. It really depends on where you draw the system boundary. For example, for the LCFS, for the point of origin, you could go all the way to the farms. For ICC, you could go all the way to the farms as well. But for some other regulations like British Columbia's Low Carbon Fuel Standard and UK RTFO, it could mean where you're gathering the feedstocks. Let's say if it's soybeans, you don't have to go all the way to the soy farming. You could look at the crushing facilities, or you could look at the silos that were collecting these soybean products. The definition for the point of origin could be different. Also, whether these sites need to be certified. Only ICC so far requires certification for different sites defined in the system. UK and California LCFS are requiring attestation letters, basically showing where these sites are, and then have a third party to verify that these sites are indeed existing. Accompanying documents would also be very different depending on the level of rigor to ensure that these are verifiable and transparent and consistent. If you add the variability in scale, some are large farms and some are small family-owned farms, their feedstock types, whether it's commercial crops or waste materials, supply issues, system configurations, unit conversions, and the human errors involving data collections. There's a lot of potential issues in the data quality and data security. You want to make sure that all these uncertainties are resolved and everything is consistently carried out. Not all these documents are transferable directly from one regulation to another regulation. You need a lot of in-depth understanding for these requirements across different regulations and making sure you're not leaving any potential loopholes or errors that's going to come back and bite you. Let's switch gear to land use change, especially on indirect land use change. Direct land use change, there's a lot of ongoing effort in collecting data, looking at soil organic carbon changes, looking at the agricultural part of the land conversions, and then how land is cultivated and maintained. Those are things that are relatively measurable. Indirect land use change is a ripple effect. You have to use economic correlations to look at the perturbations of scaling up of biofuels industry to the land competition, then from the land competition to allocate to where this land might be coming from. Are they coming from set aside land, or they're coming from land that's in the rainforest, basically the untouched and managed rainforest and clearance? And then what happens afterwards? Are you leaving the biomass rotting in the field, which they release methane, or are you actually utilizing the materials for other usage, and then how you cultivate the land? Are you managing its sustainability? There's a huge amount of assumptions and then lots of correlations that need to happen to define an indirect land use change scenario first. And then you're going to have to apply methodologies to quantify how much carbon is added or removed from that acre of land where activities are happening. There is a huge amount of effort going in from both the economic correlations as well as the physical carbon stock changes before and after the land use change. If you compare the EU definition on indirect land use change versus the California low carbon fuel standard definition on indirect land use change, big difference. The EU definition basically said the production of biofuels imply that the land use change could occur, and it implies that a substantial amount of CO2 emissions are released to the atmosphere during these activities for biofuels production. It is very soft language. It basically says implies an impact. And their approach is basically, let's raise the bar to make sure that greenhouse gas productions compared to the fossil fuels has to meet a certain threshold, and also put a cap on crop-based feedstocks. That's more of a risk-based approach to say, we think the crop-based feedstocks is going to cause potentially significant indirect land change, so let's set a cap on it. On the other side, if you look at California low carbon fuel standard, they are pretty firm on their language. They basically said some fuel production process, not all fuels, could generate greenhouse gas indirectly via intermediate market mechanisms. They don't say implies. They basically says some fuel productions will cause indirect land change, and that some fuels has to be further defined by California. And then they have pretty specific descriptions about how they want indirect land change impact to be calculated, with a specific model defined and specific assumptions they put in there. It's very prescriptive ways of accounting for indirect land use change factors. There were a lot of debates happening, concerns about cherry picking in terms of specific biofuels getting penalized versus other type of biofuels. It's going to require a lot of data gathering, a lot of validations of these calculations and some of these models as well. One of the things I will also want to highlight is all of the model recommended by EU as well as the California LCFS are based on equilibrium correlations between biofuels production versus land use change. And we all know biofuels production is still changing frequently. It depends on the price of oil. It depends on the regulatory demands. It's not a full-fledged industry. Calling it equilibrium is really not accurate. So you can tell that these are some of the fundamental issues within the current model that's being used to calculate indirect land use change. This next table is showing indirect land use change factors. The California low carbon fuel standard model, the Greek model that's developed by Argonne National Laboratory, and also the UK RTFO, Renewable Transportation Fuel Obligations. And for 3 pathways, corn ethanol, soybean biodiesel, and sugarcane ethanol, primarily produced from Brazil. And also there's the European Union Renewable Energy Directive, iLUC values for the 3 pathways. There is a big difference. The European values from UK and the EU were consistently high as compared to the US values. And even within the US, the state of California has a higher value for core ethanol as well as sugarcane ethanol as compared to the defaults in the Greek model, which Greek model usually represents the American average estimates. You're looking at more than double from the US versus European values in terms of indirect land use change. That is going to cause a big difference in terms of potential carbon reduction potentials for these three different pathways as they're being utilized in the transportation sectors in different areas and regions. My personal opinion is that iLUC is far from being ready to be an implementation tool. It is much better off as an indicator that shows us what are the potential impact could be and use regulatory encouragement for best practices or other incentives to prevent the indirect land use change. An alternative way, we really need to understand what are the direct land use change impact, because we're at the time and age that we can use a lot of data analysis where with the AI technologies available, we can do a lot more data gathering and we can use the SEPNI data to validate the land use change impact occurring at different parts of the world. Once we have a good understanding of the direct land use change impact, we can better correlate between fuels production, expansion to the land use changes in various areas across the globe. As I mentioned, I think chain of custody is a transparent and is a consistent way where people can keep track of the resource development all the way to fuel production and product end use to prevent any kind of consequences or prevent fraud in the system. So it does make sense for implementations and transactions of biofuels, improving the assurance and reducing the risk for the producers as well as the off-takers of biofuels. I think it's going to stay and it's measurable, it's verifiable, it's not perfect. The alignment needs to happen among different regulations, but I think it's really close to or ready to be implemented. Indirect land use change, iLUC, is still associated with huge uncertainties. It's really not ready to be implemented at this point. How do we want to stay in compliance with all these evolving issues, but with the mandate, right, on the chain of custody as well as iLUC? I think all the biofuels producers or the impacted parties needs to have their internal task team understand how they're impacting your own value chain. Are there any vulnerable points or hotspots across your corporate functions? Do you have gaps that you need to fill? Or do you have clarities with how it's being executed through your document transitions and your record retention systems, and then making sure you have a compliance strategy in place for chain of custody. And if you're a global company, make sure you need to have a regional compliance strategy. The best thing we could do is sponsor joint research studies or participate in trade association efforts to advocate our own positions. We need to make sure the implementation plans for all these regulations are consistent across the board. There needs to be consistency. So we don't have to do traceability and validation 3 times or 4 times for different regions. So that will save us time to get ready and make the process more streamlined and more transparent, leverage capacities across different regions we operate. And AmSpec, our goal is really to assist our clients from across the whole value chain, from the resource management, from data collection, all the way to product quality assurance, record retention. AmSpec has an in-house expertise that can help you with calculating the carbon intensities associated with your whole value chain, including understanding the impact of indirect and direct land use change. We have partners with Flux on establishing a traceability system. Flux is endorsed by both CARB as well as the EU ETS, emission trading system. They are very well accepted and their system are set up for all these regulatory compliance. You will have your data properly integrated and prepared for California LCFS compliance requirement or any of the EU RED program compliance requirements. We can also help you do the pre-audit preparation as well as assist you through the site audit. We also have capabilities in-house to assist you with the biofuels testing as well. Reach out to us if you have any questions about what we shared today, or you have any additional issues that's not covered today, but it's also related to the recent California LCFS amendments or other LCFS programs in Oregon, Washington, British Columbia, as well as New Mexico. We're tracking all these rulemaking processes very closely. And we are also the verifiers that's accredited under California low carbon fuel standards, as well as Oregon clean fuel standards. We'll be able to provide advisory services for you in terms of complying with various requirements, as well as apply for your pathway registration under those programs. Thank you for your attention. We'll look forward to hearing from you.